Hi guys, Mr. Scott here again for part 2 of the acids and bases review. So like I talked about in the last video, what you should have out, same stuff, reference table, flip to page 6. Today we'll talk a little bit about table M, as you can see below. Have a pen or pencil out and then fresh sheet of paper, or you're welcome to continue any of the notes that you made from the last video. Please just continue with those notes. Whatever works for you, works for me. So the plan for today, we're going to talk a little bit of indicators. We're going to talk table M. So again, if you don't have the reference table out, I have mine out. Get it out. You're going to need it. And we're going to do some examples with table M, and then we're going to talk neutralization reactions with some examples. So let's go. Acid and base indicators, so specifically table M. What is an indicator? An indicator is a substance that changes color as a result of pH change. So you will recall that pH scale that I had you write down in the last video. It goes from 1 to 7 to 14, where your strong acids are all the way to the left, close to a pH of 1. Neutral is about 7, where the H plus ions equals the OH minus, your hydroxide ions. Hydrogen ions equals your hydroxide ions. And then all the way to the right, where something is basic, leading toward a pH of 14. Again, that scale is super important. Make sure you know it. Indicators are chosen based on their range for color change. So if you're looking at table M, which is right here, move my picture out of the way for now, table M shows you a couple of the most common indicators. This appropriate pH range for color change is where the color will change from the color on the left to the color on the right. So I'm going to talk a little bit more about it as we go on. I'll save it, and I'm going to really explain table M coming up. But real quick, I wanted to show you an example. And with that example, I want to bring about this. So to the left of the approximate pH range for color change, to the left of this number is going to be the color here, the first color in the chart. So we're talking phenolphthalein for right now. Phenolphthalein, the approximate pH range for color change is 8 to 9. So to the left, or up until a pH of 8, phenolphthalein will be colorless. But once you hit in between that 8 to 9 range, that's where you'll get a mixture of the two colors that you see here. So for phenolphthalein specifically, it's colorless and pink, so you'll see a very light pink. This phenolphthalein is the indicator that you would have used for your titration. A laboratory that you guys didn't get a chance to do, but hopefully you'll get to see a video or something on it in the future. It's a super cool lab. I was very excited for you guys, but we got to deal with what we got. Then to the right of the approximate pH range is the second color. So let's get this out of the way up here. So for phenolphthalein, at a pH greater than 9, you'll see a color that's pink. So this would be the time. I'm not going to have you write down table M. Write down anything that you'd like on this slide. Make sure that you write this stuff down and you have this example. If these tips off to the left help you, you're more than welcome to write them down as well. Take a second, pause the video, write down anything you need. Table M practice. So again, this video has it has less slides, so I incorporated some practice to go along with it. So in the example here, I'm basically using everything that we talked about in example 1 here with phenolphthalein, and I just changed up the indicator. So we're talking methyl orange. So methyl orange turns blank in a solution with a pH less than 3.1. It turns blank in between 3.1 and 4.4, and then turns blank at a pH greater than 4.4. So if you have your reference table out like I do, take a second, try it on your own. I'm not going to stop the video, but if you need to, pause the video, try it out on your own. Take 30 seconds or so. Try to find the colors without my help, and then we'll go over it. So methyl orange, you'll see that the color change is from red to yellow. So at a pH less than 3.1, the color is going to be the first color listed, so it should be red. This first blank is red. Then, with a pH in between 3.1 and 4.4, which is the approximate pH range for color change, what is the combination of red and yellow? You would get orange. So the indicator and the solution would look orange in between a pH of 3.1 and 4.4. And then finally, once you get to a pH greater than 4.4, you will see a yellow color. Here are a couple more examples. So I've written out 3 of them that I have the answers to. So what I want you to do is right now pause the video, try these examples out on your own. Write the example out, then give an answer for what you think it might be. And then I will go over the answers. So the answer to example 3, I believe all the example answers are going to come up at once. Yeah, they are. So the answer to example 3 is green. So if you look at bromethymol blue at a pH of 6.4, that is in the middle of the approximate pH range for color change, the middle of the chart of table M. And you'll see that the color changes from yellow to blue. So what does yellow and blue, the mixture of yellow and blue makes green? For example 4, what is the color of bromcresol blue at a pH of 5? If you take a look at bromcresol blue, the approximate pH range for color change is 3.8 to 5.4. So again, this color, the color that you're looking for, is whatever the mixture is of the 2 colors that are listed. So again, it's yellow and blue. But you can see that the pH range change is different from that of bromethymol blue, which is why it's important to have both that could be the same color. So the color of bromcresol blue at a pH of 5 would again be green because it's a mixture of yellow and blue. Then finally, what is the color of phenolphthalein at a pH of 8.5? So you'll see that 8.5 is directly in the middle of your approximate pH range for color change. And using the example that we had last time, phenolphthalein would be light pink at a pH of 8.5. Hope this makes sense. If you have any questions, I know I went through it quickly. Please, you know where to find me on Remind through email. You could ask Miss Miller or I. Either of us would be happy to help you. Neutralization reactions. So this is a lot. You have it in your notes, but I would suggest writing it down again. It's something that's really important and something that will come up in the future, I'm sure. So when an acid and base are mixed together, the acidic ions, the hydrogen ions, your H plus ions, and your basic ions, the OH minus or hydroxide ions, form water. HOH, more commonly seen as H2O. Also formed is this thing called a salt that we talked about a bunch. At least in the solutions unit, we talked about it a bunch. So we'll talk a little bit more about a salt as we go through these couple slides for neutralization reactions, but this is a neutralization reaction because ideally the acid and base would be neutralized. Neutral is your pH of 7, so that's when something is neutralized at that pH of 7. So acid plus base equals water plus salt. Your acid, again, H plus, and then your basic ions, are your OH minus. That will lead to the HOH or H2O and then a salt. A salt is just an ionic compound, which I believe we'll talk about in the next slide. This would be the time. Pause the video if you need to and write down whatever will help you out. So part 2 of neutralization reactions. I have an example. HCl plus KOH. So your hydrochloric acid plus potassium hydroxide. This will lead to, just like we talked about, since it's an acid and a base, if you were to write out how these are broken down, you would get that HCl becomes H plus Cl minus, and your KOH becomes K plus OH minus. Since you have the H plus and the OH minus, they will come together to form water. You'll also get this salt that we've been talking about. A salt is just an ionic compound, a metal and a nonmetal. So this is what everything is classified as I just talked about. The H from the HCl and the OH from the KOH form the water, just talked about it. And then your Cl from the HCl and the K from the KOH form your salt, your ionic compound. Again, this is a double replacement reaction, so your H and the K are essentially just switching. If that helps you to draw out the arrows, please do. But what my mouse is doing here is the double replacement that we talked about. Again, a salt is just an ionic compound. K plus and Cl minus are known as spectator ions. Again, everything in Regents chemistry is a lie. There's a lot more to this story, but for right now, that's really all you need to know. So this would be the time. Take a second, pause the video, and write this stuff down. Neutralization reactions, part 3. So example 2. Write the formula and balance the equation for sulfurous acid combined with calcium hydroxide. Now, where would you find this? What is sulfurous acid? It's actually, of course, right on your table K. So the reference table, right at the top of page 6. Sulfurous acid has the formula H2SO3. And then you should know calcium hydroxide, of course, is right in the common bases chart that you can see here on the screen, that on my screen. So you'll end up with H2SO3 plus CaOH2. And again, those two formulas are given to you on table K, on table L. In the arrow, the reaction forms water and then your salt. Here your salt is, we'll talk more about the salt. So what I wanted you to do is this equation balanced? Let's recall our balancing. It's not. Hint, hint. So if you want to pause the video, take a second, and try and balance it. All you need to balance the equation is this 2 here in front of the H2O. So you'll see that there's 2 OH minuses to balance out the calcium hydroxide to make that a neutral compound. And then you have your H2SO3. Since SO3 is sulfite, the sulfite ion, which you would find on table E. So don't forget about your table E if you ever need to find the name of a polyatomic ion. So what is the name of the salt formed in this reaction? This salt, all the way over to the right. What's the name of that? Take a second, try and find it on your own. Again, use table E. I just said the name, but use table E and come up with the name for the salt formed. The name of the salt is calcium sulfide. So I hope that these couple videos were helpful to jog your memory on acids and bases. Mrs. Miller and I are still working on what's coming next. When we know, you'll know. And we're going to be coming out with these videos on Monday. And of course, you have until Sunday to basically do it, work on it, see what you still remember, see what you remember about acids and bases. Otherwise, again, like I said at the end of the first video, I hope these videos are finding all of you safe, happy, and healthy. You know where to find me or Miss Miller if you ever need anything. If you need to talk, need to chat anything out, you know where to find us. If you have questions, again, through Remind, through email, that's why we're here. We want to help you guys. We're here to help you. If you have any suggestions, anything that you didn't like, anything that you believe would help not only you out, but others out, let us know. That's why we're here. We're trying to make this work for everyone as best as we can. Stay safe, guys. Hope to hear from you soon.